Okay, so we have a nice function here. Looks like a polynomial. We want to find the y-intercept, determine end behavior, determine the zeros and their multiplicities, and sketch a graph. So this one here is going to be a little bit of a slam dunk for us because most of the hard stuff is done for us already. As long as we don't have to factor the polynomial, we can really just get all this information just almost immediately. So, I mean, if it is multiplied out and it's in standard form, which is the multiplied out version, then we will have to do a little bit of work. We will have to factor it, but some of these are gonna, they're gonna give it to you factored, so we can go for it. All right, well, let's find the y-intercept first. We know that when we're trying to find a y-intercept of a function, that's just where x is equal to 0. So all we're really going for is p of 0. What's that? So we can find that real quick. P of 0, let's do this down here. So P of 0 is negative 2 times 0 plus 5 times 2 times 0 minus 1 square. I really don't think we're going to have too big of a problem with this. Just, compute a function value, no problem. So this is negative 1 square, that's positive 1, so we got negative 10. So our y-intercept is 0, comma, negative 10. All right, so we've got that piece, and off we go. Determine end behavior. So end behavior, we talked about this in the other video where we had to construct a polynomial. The end behavior is determined by the leading term. This is, I wrote it on the other side, or I printed it out on the other side of this sheet of paper. So let's take a look at this real quick. So end behavior of a function. Now this here, a times x to the n, this is just our leading term. So if we've got an even degree, then we're gonna look at this box. If we've got an odd degree, we're gonna look at the box down here. So let's take a real quick look at what our degree is. So if we were to multiply all these numbers out, the largest degree I'm going to get from this term is going to be, well, the square of that. So that's going to be 4x squared. The largest degree term of this is going to be the square of the first one. So that's going to be 4x squared. And then the largest degree term, if I multiply this this term by the term before it, x plus 5, I would have 4x squared from this one times x would be 4x cubed. And then I would multiply the largest term that comes out of this product by negative 2. So 4x cubed times negative 2 would be negative 8x cubed plus something, something, something. So the other stuff really doesn't matter. This is the part that matters. So if we multiplied everything out, this is a square, so the largest term is going to be the square of the first term. So we got 4x squared times x would be 4x cubed times negative 2 would give us that negative 8x cubed. So there's our leading term, and that's going to tell us what the end behavior does. So let's take a look at the other side of the sheet. So we know our leading term is negative 8x cubed, so it's got an odd degree, and it's a negative leading coefficient. So let's take a look real quick. All right, so we've got an odd degree, so that tells us, hey, we're in this box. And we had our leading coefficient was negative 8, so that's in this spot here. So negative 8 is less than 0. So that means as x goes toward negative infinity, so as our graph goes to the left, our function value is going to go up. And as x goes toward infinity, which is going to the right, then our function value is going to go down. So we're looking like this. So we can write that in our... Okay, so we found the y-intercept, that's wonderful. Now we're determining end behavior. So we can maybe just write this up in a neat little package here. So the leading term is negative 8x cubed. So that tells us that as x goes toward negative infinity, our function value is going to do something. As x goes toward positive infinity, that means our polynomial is going to do something else. Okay, so leading term is negative, so that means it's going to go down on the right. and that means it's going to go up on the left. All right, so there is our end behavior, and that again comes directly from what the leading term is. If we have an odd degree, then the end behavior is going to be opposite, right? One's going to be up, one's going to be down. If our leading coefficient is positive, then it's going to go up on the right. And if our leading coefficient is negative, that means it's going to go down on the right. So that's what this is. As x goes toward infinity, that's to the right. Then our function goes down. Okay, so we've got the y-intercept, we've got the end behavior, boop, and now we can determine zeros and their multiplicities. So this is another application of that nice factor theorem. We're just going to use it the other direction that than what we used in the previous video. So we know, I'll just rewrite this. P of C equals 0 if and only if x minus c is a factor of p. So this is the factor theorem, right? So some number gives us a 0 out of the function if and only if x minus that number is a factor. So let's take a look at, I'll just rewrite it again. I don't want to keep going up and down with the paper. All right, so c is a 0 if and only if x minus c is a factor. Okay, so we can see this, right? So the number that we're going to get here is going to be -5. And the number here is going to be whatever makes this 0. So this is going to be x equal 1/2. If we want to, we could just set each of these factors equal to 0, because that's what we've done in the past, right? And we could just use that zero factor. I don't recall what this textbook calls it. Zero product property. If we have a string of numbers and we're multiplying them all together and we need to have it be 0, well, one of those factors has got to be 0. We can find this one by just setting this factor equal to 0 and solve for x. We can find this one by setting this factor equal to 0 and solving for x. And that's, another way to think about it too. Okay, so we want to define the zeros and their multiplicities. So we've got the zeros here, and then we want to just say what their multiplicities are. So essentially the multiplicities are just how many times the factor appears in the factorization of the polynomial. So this one, right, we're just looking for the exponent here. So if it's not written, it's 1. So that's got multiplicity 1. This one here, the exponent there's 2, so that multiplicity is 2. What the multiplicity is going to tell us is when we draw our graph, it's going to say whether or not the graph of the polynomial crosses the x-axis or if it just touches the x-axis when we go through it. And so we've done it. We found our zeros, we found our multiplicities, and now we have one more thing to do, which is to sketch a graph. So really all we're going to do is just, put all this stuff together. I'm kind of switching back and forth between purple and green here, but let's draw our next picture. So we need to have 0. Let's just put all of our stuff on there. So our y-intercept was -10, so the point 0, -10 is on there. So we can put 0, -10 on there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Boop. All right. Then we have our end behavior. So as we go to the left, we're going to go up. And as we go to the right, we're going to go down. All right, there's our end behavior. Now we have our zeros. So these, again, are x-intercepts, and we can put them on there too. So 0, 1, 2, 3, 4, 5 in the negative direction. There it is. And we've got x equal 1/2. So that's like there. All right. So now, so at this point, we know it's a polynomial. We know we're drawing a graph. We know that the domain of all polynomial functions is all the real numbers. So that means that the graph is continuous, right? So that means that once we have this framework, we can just connect the dots, right? We should use our multiplicities. We should be having that in the back of our heads just in case we, come into a situation where we don't know what to do. our multiplicities are going to tell us what to do. So let's just move left to right here, and we can draw the picture. We know it has to end going up on the left. That's wonderful. We also need to know, the graph has to go through this point. Somehow, some way, it's got to go through that point. Now, once we get here, either we can look up here and say, hey, the multiplicity is 1, so that means it's going to cross. Or we can say, well, I've got the choice of two things. I can either go up or I can go down. As I'm moving to the right, I can either go up or I can go down. Well, if we go up, we know that we're going to have to cross through this point at some point. If we go up, to get down to -10, we're going to have to go back down. So there would have to be another x-intercept somewhere in here. But we've already shown that there isn't. These are the only x-intercepts. We've already shown that. So we know that we can't go up. So again, either we're going to rely on our knowledge of the multiplicity and what that means, or we can just use logic and say, well, the switch is either on or off, and if I can show that the switch is not on, then the switch has to be off, right? If you got two options and you can show one of them can't be true, well, it's got to be the other one. Just specifically, I can't go up because there isn't another x-intercept here for me to go down through, right? So we have to go down. La-di-da. So we're through there. And then we know that after we come out of this point, we're going to have to go back up and touch that. Kind of thin there. We got to touch that x-intercept. And now we can, do the same thing we did with our previous multiplicity. Either we can note that, well, I'm either going to go up or I'm going to go down. If I go up, then we're going to have to come back down, so I'm going to need another x-intercept, but we don't have one. So we're forced to bounce right back and go down. So we can use our multiplicities there to say it just touches at the x-axis there, and it continues to go down. So I know that this graph isn't terribly beautiful. But the ones, when the computer's going to ask you to do this, it's going to give you options, choose between the four, and you're going to have the features of the graph. The real important parts are your end behaviors, your intercepts, and, well, multiplicities, I suppose. Like what it does it go up or does it go down? So that was that.